Good evening. Now we will go questions which may ask on your sheet number 5 and 6. Now keep in mind, we are going through all this. You have to see your term work, and whatever questions I have given on theory part, you have to go to playlist and you have to see this question. You have solved your question, gantry girder, you should be in position to answer all things. Design steps you should know. For trusses you should know design steps, and for welded plate girder also. Now all these tension member, compression member, so whatever problems we have solved, you should know all these steps in this. Now we will go for sheet number 5, and then we will switch over to sheet number 6. So first we will go sheet number 5. Now in this we have two types of diagrams actually. One diagram we have that is space diagram, and second we have that is vector diagram. So we have these two diagrams for dead load, and then we have two diagrams that is for wind load. Now we have not plotted for live load because whatever value we are going to get from dead load, from that value we are going to find value of force in member due to live load. So simple force in member due to live load equal to live load upon dead load into force in member due to dead load. Because here we have to actually only change the scale. Now you have first question, why you are going to use graphical method. How many methods we have in trusses? We have three methods. First method we have analytical, or we can say joint method better. So we have to consider each joint separately and then apply Fx0, Fy0, and then find forces in all members by considering each joint separately. Then we have section method. We have to consider section, and then we have to take moment or Fx, Fy and then find the values. Now, when we will go for this method, actually this method is lengthy. And when you have fixed forces acting on the joints, then we will prefer joint method. Section method, if we have to find force in any intermediate member, then we will prefer this method. Or we have to check randomly forces calculated by joint method and forces calculated by graphical method, then we are going to use section method. And when we will go for graphical method, so this method we will go when your loads on joints are same. We can use for any. Here we are going to say loads on joints are same here because for this, and therefore we are preparing this because we have to just use scale, and by that scale we can find forces in member due to live load. We need not require to calculate it separately. Now this graphical method means in calculation of this, if our value of dead load is wrong, suppose we have calculated value as 2 kilonewton, and after showing it to your teacher, he is shown some mistake, and then that value goes to 3 kilonewton. Then your graphical method is unique for a truss. For a truss, if your loads are in the same way. So now here in first case, if you have used 1 centimeter equal to 2 kilonewton, and now you come to know that you have committed the mistake, then you have to go scale 1 centimeter equal to 3 kilometers. So unique for a truss, and therefore we are going to use this method, that is graphical method, in this analysis of truss. Now you can have what is space diagram. So we have this truss and we are using Bose method. And in this Bose method, he clearly mentioned you have to give names to spaces which are between names to space between load and load, reaction and load, reaction and reaction, and member and member. So whatever space we have between these, we have to give names to this, that will known as space diagram. So now you can see this. We have, these are the forces, dead load, and then now we have space between this reaction and between this load. So we have, this is named as A. Now we have space, this space we have to name. This is between 1.01 to 2.02. Then this space between 2.02 to 2.02. So A between reaction and load. This space, now B I have given between load and load. Then we have given between load and load likewise. So we have given space likewise. Now this space is between M we have given. This is between reaction and reaction. You can see this, between reaction and reaction. So generally, between loads and reaction, between reaction and reaction, so values known of the reactions and loads, that space are generally denoted by letters. And space between the members, now you can see this, between these members. So we have space as 1. Now between these members, we have this space 2. Similarly 3. Likewise, we have to give names to this, and that will be your space diagram. So in oral examination, he may ask you what is space diagram and can you show space diagram? Then you should be in position to show this diagram by giving these names to different spaces. Once this space diagram is plotted, then we have to switch to vector diagram. And this vector diagram we are going to use to determine forces in members. Now he may ask how you will plotted this graphical method, or then you should be in position to answer this question. Now you can see I have shown this. And now see very carefully, he may ask you explain. So now you can see we have, this will be AB. How much force we have? 1.01. We have considered scale. So scale we have taken as 1 centimeter equal to 1.01 kilonewton. Then we have this 2 centimeter BC. Now this 1.01 is named as AB. It is not known as 1.01. It is known as AB. This 2.02 is named as BC. This 2.02 named as CD. Likewise, we have plotted till L. So now you can see this. And all are in downward direction, BC, CD. So we have plotted all these in downward direction till L. Now L to M, we have this is in upward direction. Now we have this as 1 centimeter equal to 1.01. So this becomes your 10 centimeter. And now you can see this. So we have this as 1 centimeter. This will be 2. Then we have blue 2. This again 2, 2, 2, 4, 6, 7. This 2, 9. And the center of this green. Till that we have to go for this. you just see carefully whatever color are given to the forces, same colors I have plotted it for their values. So AB red color, so I have plotted 1 centimeter. BC we have yellow, so I have plotted it yellow. Then green, likewise. Last you can see I have shown 1.01 black, so I have shown 1.01, 1 centimeter black. Now we have pink, so I have plotted it till center of green. I already mentioned, and that you have, that is pink. And then dark green we have next 10.1. Again, this is in upward, so plotted L to M upward. And then similarly M to A upward, so plotted it in upward direction. So this is your closed polygon. He may ask you what this diagram is known as. This diagram is A to L and L to A. This is known as closed polygon. And what it shows closed polygon, it shows your resultant value is 0. If your starting point is A and you are coming back to A, means you have closed polygon. When starting at end points are same, it is known as closed polygon, and that shows your resultant is 0. That means your truss is in equilibrium condition or in equilibrium. And therefore we can apply fx0, fy0 likewise. Now we have plotted all these letters. Now we have to plot numbers. So now how we will plot this number? We will draw a line parallel to B1. Now this member is known as B1 member. And then second we have this member which is known as M1. This is M. So for whole this portion, you have space as M. So to know M, I know B, I know M. I will draw line parallel to B1. I draw line parallel to M1. An intersection of this gives me M. So you can see this. So this will be 1. Now if you have to plot 2, then now 1 I know. I will plot 1, 2 over here. And I will plot C2, this one, where I have 2 as common. I know 1 point, I know C point, and for 1, 2 and C2, these two members, 2 is common. So I have plotted this. So this will give me 2. So likewise, next we have 2, 3 and M3. So 2, 3 and M3. So we have this as 3 point. So likewise, you have to find all these points. I have plotted all these points, and likewise you are in position to have this graphical method. Now how to find force? Now force in this B1. So I will measure this B1. You have to measure this length B1, sorry. B1 we have this. We have to start from 1 and we have to go to this. So measure this length from this to this. And multiply it by scale. What is scale? 1 centimeter equal to 1.01. And that will give you force in member B1, this member. Then measure M1. So just I have shown before this. So measure this M1. Multiplied by 1.01. We have that scale. You will get force in this member. Likewise, then 2, 3, force in this member. If I have to find force in this member, then I have to measure 7, 8. So we have 7, 8 this. And then likewise, you have to find force in the members. So likewise, we have forces in members. Now, how to find nature of the forces? Now just see. Now let us, I have to find force in C2 or 2, 3. Then I have to consider joint, this joint, or I have to consider this joint. Choice is yours. So let us, I have considered this joint. I will mention this as capital C. Now see, what are forces, what are members are there? So this 2.02, blue, 2.02. Then I have this as small c. Then this member 2, 3. So I will draw this member 2, 3. Then I have 3, 4, member vertical. I have 3, 4. And then we have, this is again CD point. Now we have this capital C. And we are interested to know the nature of the member. So if they have asked you how you will find nature by graphical method, so you have to consider that joint. Now I have considered C. Now according to Bo, you have to go clockwise. Now we have to find nature in D4. So this member. So now we are going from D to 4. Where I have D, we have D over here. Where is 4? So 4 is here. So I have to go down. I have to go down to go to 4. So down I have to show here. Means we have compression towards the joint compression. So we have compression in this map. Now 4, 3. Now 4 we have here. 3 we have here. Where we have to go? We have to go up. So 3, 4 we have to go up. Then again we have compression in this member. 3, 4. Again we have compression. Now 3 to 2. Now where we have 3, we have here. 2 where we have here. So we have to go 3 to 2 downward. So downward. So we have 3 to 2 tension. So we have force in this member tension. And then 2 to C. So we have 2 over here, C over here. So 2 here, C here. So we have to go from 2 to C. We are going upward. So we have to show upward. Again, we have compression. So in this member, again, we have compression. So taking that joint, taking clockwise direction, D to 4, D to 4 coming down. So at that joint, you have to show downward. So likewise, you have to give this nature of the forces in members. Then we have space diagram in the same way. Now keep in mind, your wind load is always perpendicular to the principal rafter, and that is always away from the roof. Always keep in mind, it is always away from the roof. And therefore our reaction is always in downward direction. And now for this, you have only a small change for this diagram. Now you can see AB. So you can see AB. Now it is an angle. What is this angle? So now you can see, let us you have this as theta. This will be 90 minus theta. Sorry, vertical we have 90 minus theta. Now these two are perpendicular. So this is theta. So with vertical you have theta. So you have this vertical theta. And that you have to plot it. AB red, then BC yellow. Similarly, we have this parallel to these forces. We have parallel to these forces. Now you can see we have with L. Now LM we have now in downward direction. So you can see in downward direction. This is vertical and then downward. So again, this is closed polygon. And closed polygon means resultant is 0. Now the change you have, here you have N, one extra letter, because in a dead load, we have at a ridge, vertical force downward. Here you have two forces which are perpendicular to the rafter. Now why this value is half? Because this joint have values of the loads from both sides. Whereas for this 4.3, we have only from right side. Left side, we do not have anything, therefore no load. But for all other joints, we have from both sides, half. And therefore value at intermediate, we have doubled. Whereas at end panel point, we have half of the intermediate. And likewise, we have to go for same way, whatever we have done for your dead load. So this is about your vector diagrams. So now we will stop here only. In next video, we will go next part. So thank you.